Under the cold, infinite darkness of space, the James Webb Space Telescope has begun to whisper secrets that threaten to upend the very foundation of modern cosmology. Imagine for a moment that everything you thought you knew about the universe, its birth, its structure, its fate, was suddenly cast into doubt. This is not science fiction. This is the reality now facing astrophysicists, cosmologists, and theorists worldwide as the Webb's unprecedented vision peels back the layers of the cosmos, revealing anomalies and contradictions that no established theory can comfortably explain. For decades, we have trusted in the elegance of Einstein's relativity, the mysterious scaffolding of dark matter, and the relentless push of dark energy. But what if these pillars are merely shadows on the wall, and the true architecture of the universe is far stranger than we ever dared to imagine? Let's begin with gravity, the universal force that binds planets, stars, and galaxies together. According to Newtonian and Einsteinian physics, gravity's pull weakens with distance, a principle as reliable as the sunrise. Yet, in the 1970s, Vera Rubin's meticulous observations of galactic rotation curves revealed a paradox. Stars at the periphery of galaxies were orbiting just as rapidly as those near the core. By all rights, these stars should have been flung into intergalactic space, but they remained bound, as if held by invisible hands. This led to the postulation of dark matter, an unseen mass that exerts gravitational influence without emitting or absorbing light. For decades, dark matter has served as the invisible glue holding galaxies together, shaping the cosmic web and leaving its fingerprints in the cosmic microwave background. But now, the James Webb Space Telescope is forcing us to reconsider. Its deep-field images have uncovered galaxies at distances, and thus ages, previously thought impossible. We are seeing mature, massive galaxies that existed when the universe was a mere 200 million years old. Some, like the recently identified J0107a, dwarf our own Milky Way in size and complexity, despite originating in an epoch when the universe should have been too young and chaotic for such structure to exist. According to the Standard Model, dark matter halos should have shepherded normal matter into galaxies over billions of years. Yet here, we find evidence of fully formed, orderly galaxies almost at the dawn of time. Is dark matter not what we thought? Or have we fundamentally misunderstood the early universe's conditions? The challenges do not end with dark matter. The so-called S8 tension has emerged as a persistent thorn in the side of cosmologists. S8 quantifies the clumpiness of matter on large scales, derived from both the cosmic microwave background, CMB, and the distribution of galaxies today. The values do not match. The early universe, as seen through the CMB, suggests a higher degree of matter clustering than what we observe in the present-day universe. This discrepancy is statistically significant and cannot be dismissed as mere error. Are our measurements flawed, or is there a deeper, unrecognized process at work? The Webb's data only amplifies these questions, hinting at unknown physics lurking beyond the reach of our current models. Dark energy, too, is under siege. For years, the accelerating expansion of the universe has been attributed to this enigmatic force, characterized by the Hubble constant. Yet, measurements of the Hubble constant derived from the early universe, via CMB, and those from the local universe, using supernovae and other methods, are in stark disagreement, a conundrum known as the Hubble tension. Recent observations even suggest that dark energy may not be a constant at all, but a dynamic entity that evolves over time. If this is true, the implications for cosmology are profound, demanding a re-examination of the fundamental forces shaping cosmic evolution. Perhaps the most staggering revelation concerns the cosmic microwave background itself. the faint afterglow of the Big Bang, long regarded as the definitive proof of our universe's fiery origin. New research proposes that the CMB may not be the primordial light from the birth of the universe, but rather the accumulated red-shifted radiation from countless early galaxies teeming with hot, young stars. If even a small fraction of the CMB's energy comes from such sources, our interpretation of this signal, and thus our understanding of the universe's age, structure, and origins, could be fatally flawed. The very evidence that underpins the Big Bang theory may be less certain than we believed. The Webb's revelations do not stop at challenging existing theories. They also hint at entirely new paradigms. In a survey of over 30,000 galaxies, Webb found that an overwhelming majority share the same rotational direction, a level of cosmic order inexplicable by the Standard Model, which predicts a chaotic, randomly oriented universe. The further back in time we look, the more pronounced this alignment becomes. Such a pattern suggests an initial cosmic spin, a feature for which no current theory accounts. If verified, this could force a radical revision of our understanding of the universe's birth and evolution, perhaps even pointing toward new physics beyond Einstein. And then there is the most audacious hypothesis of all, that our universe itself may be the interior of a colossal black hole. Recent work by researchers at the University of Portsmouth posits that instead of beginning with a singularity of infinite density, the universe emerged from the gravitational collapse of a previous cosmos, rebounding into expansion. In this scenario, our universe's boundary is the event horizon of a black hole, beyond which nothing, not even light, can escape. This cyclical model echoes Roger Penrose's conformal cyclic cosmology, in which universes are born and die in an eternal sequence, each leaving subtle imprints on the next. If true, this would mean our universe is not a unique creation but part of an infinite cosmic lineage, each iteration governed by laws we are only beginning to glimpse. All these findings, from the anomalous galaxies of the early universe to the possible misinterpretation of the CMB, and the tantalizing hints of a cosmic spin or black hole origin, converge on a single, unsettling truth. We may be standing at the threshold of a scientific revolution. The James Webb Space Telescope, with its unparalleled sensitivity and reach, is not merely refining our understanding of the cosmos. It is dismantling it, piece by piece, and compelling us to confront the unknown. For the experts in the field, this is both exhilarating and terrifying. The comfortable certainties of the past are dissolving, replaced by a sense of profound mystery and possibility. What comes next is uncertain. Perhaps new physics will emerge to reconcile these tensions, or perhaps entirely new frameworks will be required. What is clear is that the universe is not the static, comprehensible entity we once imagined. It is a dynamic, evolving, and fundamentally mysterious realm, and our journey to understand it has only just begun. As we peer ever deeper into the cosmos, guided by the unblinking eye of the Webb, we must be prepared to question everything, even the very foundations of reality itself.